Welcome to a video on counting ordered selections. So through this topic, we will be looking at whether you need to have whether your selections are ordered or unordered, and if they're ordered, whether there's repetition. And we're going to learn a couple of little ways that you will remember and also things to watch out for. So the first thing we're going to look at is the multiplication principle. So suppose there's a selection is to be made in 4 different stages. So we could be looking at, whether you're going to choose a shirt for the day, like if you're going to work, where you had to choose a shirt, pair of pants, a tie, a pair of socks to wear. So they would be 4 different stages. Going to a restaurant could be an example. You might start with an entree, main, dessert, and a drink. That'll be 4 different stages. So we consider the first stage can be made in N1 ways, the second stage in N2, the third stage in N3 ways, and the fourth stage in N4 ways. So the total number of ways would then be the multiple of those different stages. And this would multiply or would continue for any number of stages that we happen to have. So here's an example with 3 stages. So we've got entrees, mains, and desserts. So there's 4 entrees to choose from, there's 10 mains and 7 desserts. And what in theory you're looking at is in how many different ways could you go back and have a different meal or a different combination of meals every single time. So that is a different entree, main, and dessert combination as you go through. So the total number of orders is the entrees, number of entrees, times the number of mains, times the number of desserts. So that's 4 times 10 times 7. So you could return 280 different times before you actually get, and have a different combination every time. Let's look at our next example. So from the 26 letters in the alphabet, how many 3-letter words can be formed? And then we're going to have a look at how many of these words contain at least one vowel. So with the 3-letter words, obviously we can have repetition. So that's 26 times 26 times 26, assuming that each letter can be used more than once. So it's 26 cubed. So the number of 3-letter words is 17,576. What about if they've got to have at least one vowel? So we've got a restriction here. We're going to first count the number of 3-letter words containing no vowels, which is 21 times 21 times 21. And then we subtract that from the total number of letter words that we had before. And that's 26 cubed minus 21 cubed, which is 8,315, have at least one vowel. So now we're going to look at ordered selections without repetition. And this is going to introduce one of our formulas. And we're going to be able to use factorials on some of these, as factorials involved when you choose your objects, they diminish by 1. So we know that 7 factorial is 7 by 6 by 5 by 4 by 3 by 2 by 1. We don't necessarily have to go all the way down to 1, but we're about to use that as examples as we go through. So in a cricket team of 11 players, how many ways can a captain and a vice-captain be chosen? So the number of ways is the captain times the vice-captain. So once you've chosen your captain, then the number to choose from diminishes by 1. So you've got 11 players to choose from for a captain, because we assume that that same person can't hold both positions. So that's 11 times 10. So this introduces our first formula, which is involves permutations. And permutations are the number of ways that are secondary arranged, and we don't have that repetition. So order is important. So when we do permutations, you've got to remember that your order is important. And the formula is NPR equals N factorial over N minus R factorial. You will find the NPR button on your times button on your calculator, and we'll use it in a little bit. So R is the number of objects that can be formed from a set of n distinct. So you've got n is the total number of distinct objects that you have, and R is what we're focusing on. So using our cricket team example again, so we had that 11 players and we wanted the captain and vice captain. So n was the number of distinct objects that we're looking at, so 11 in this case, and we want to pick a captain and a vice captain, so we want to pick 2 from that. So the order is important because choosing the captain we assume is important. So that's that's the first position to choose, and the vice captain is the second position. So the order is important. So this becomes 11p2. Now on your calculator, if you want to do this, you can go 11 shift times button. That'll get you the p2, and that will get you 110. But using our factorials, it's 11 factorial over 9 factorial. That's 11 times 10 times 9 factorial. Then the 9 factorials cancel, so you get 11 times 10, which is the same as we did for the last one. So as mentioned earlier, one of the things that we make sure we deal with first is the restrictions. So that's a general guide. So for this one, here's an example. So we've got a 4-digit number has to be greater than 5,000. We want to know how many we can get using the digits 1, 3, 5, 7, 9 if no repetition is permitted. So the no repetition means it's permutations, or could be permutations. And obviously the order is important because having a 1 first compared to having a 9 first changes the value of the number. So the order is important. And it's got to be greater than 5,000. So that means that that first digit is really important. So it can't be a 1 and a 3. So order is important. The restriction, so we're focusing on that first digit. So only the 5, 7, and 9 can fill that first digit to make it a 5,000, 7,000, or 9,000 number. So that's 3 numbers can fill that first one. The remaining 3 digits can be filled by any other of the 4 remaining digits once you put one of those first ones in. So that first digit was 3 possibilities times, and we've got 4 to choose from, but we only want to choose 3. We've got 3 positions. So 4 digits, 4 remaining digits to choose from, 4 remaining numbers to choose from, and we want to fill 3 digits. That's 4p3 because the order is important for those. And if you answer that on your calculator, you get 72. Thank you.